Hey, good morning, folks. Can you hear me?
Yes, ma'am.
Hope you all had a nice festival yesterday. So, we'll start with the class. Hope you can see this Microsoft whiteboard that I am showing right now. So, we'll discuss a quick recap on what we discussed in the last class. So, we talked about, just a minute. We talked about oh, yeah, we talked about network edge. Okay, this was the topic discussed in the last class. So under network edge, we discussed about end systems. So end systems, by now you should know end systems are nothing but they are also called as hosts. They are nothing but the client and servers, which to the internet, a client also avails internet, servers also avails internet. So they are the end systems. So nothing much to talk about it. So next we moved on to access networks. So in that we discussed about edge router, something called as edge router, the first router that's connected to the host, right? Then we talked about how this edge router is connected to the network. So there are ways. So residential or home access. All right. One more is enterprise access, right? Under residential, can you recollect what all we saw? So we saw under residential or home access, we saw these technologies like DSL, digital subscriber line, cable modem. All right. Under cable modem, we saw one more variation of called as hybrid fiber cable. So in DSL, it's just a different kind of physical medium. In cable, here you will have DSL AM. Here you will have cable modem as well as CMTS, which is cable modem terminator, switch or something. I am not able to recollect that name. So hybrid fiber coaxial. When it comes to a normal cable modem, it's just everything with a normal coaxial. Here, when it comes to hybrid, it is a mixed of fiber optics and coaxial cable. So we are going to see what fiber optics coaxial cable in today's class. So don't worry about the physical medium. Just understand which physical mediums are used in which networks. All right. Then we saw about a technology called as FTTH, which is fiber to the home. All right. This is not much used in developing countries, but already the developed countries like Singapore, um, mm, Japan, all those countries has started using this fiber to home. This technology is completely of fiber optics. So you can imagine the transmission rates, it's going to be definitely high. All right. So this is about what we saw in residential. So in residential, apart from DSL cable modem and FTTH, if these are not available in certain location, then they can use this dial-up, which is very, very slow, or they can use satellite access too in places or in location where DSL or cable modem or FTTH doesn't work or cannot be implemented, dial-up or satellite access can be taken. All right, this is about residential. Then what we saw about enterprise. So enterprise takes both Wi-Fi and Ethernet. So when I talk about enterprise networks, so it's about both wired and wireless. So when it comes to wireless, it's Wi-Fi, and when it comes to wired, it's Ethernet LAN. All right. So these two we saw in enterprise access. Now these Wi-Fi is used in home access too. That also we saw a picture where Wi-Fi is used in home access too nowadays. All right, this is altogether a gist about network edge. All right, having said this, so when I taught you network edge, I have told you there's a physical medium, and I've told you DSL will have a twisted pair, or cable modem has taken this coaxial cables, all those things. Now you would be wondering, what are these? These are the physical mediums that links to end systems, like it could be end system or host getting connected to a router to the base station again to a different host. Okay, altogether how these components are getting linked. Okay, so that's about today's class. So today's class we will be seeing about physical medium. So I'll choose physical medium. Okay, so just a quick gist before I get on to the PPT. So there are two types: guided. All right, under guided you have three categories. One is twisted pair, one more is coaxial cable, which is often called as coax. Okay, it's just called as coax. All right, and one more is fiber optics. So these three falls under guided media. All right, there's one more category called as unguided media. Unguided media, there are two. One is radio waves or radio channel. The other one is satellite channel. So now you can see, so whichever is wired falls under guided, whichever is wireless falls under unguided media. All right, so physical medium, guided, unguided. So now we'll just have a quick look on what all we are going to see in guided media. Okay. So what all we are going to see in guided media. The first one that we are going to see is twisted pair. Twisted pair cable. All right. So it looks like this. And probably you would see you would have seen this kind of twisted pair cables at your home, or probably if you haven't seen this, when you go to your grandmother's home, it's a very older technology. Like when Graham Bell wanted to invent this telephone, he was quite confused, where he wanted two, wires, which one takes the incoming signal and one, is helpful for sending the signal, outgoing signal. So he wanted two wires basically working all together. All right. So luckily, twisted pair came those dates only. So he used twisted pair to connect telephone lines, for one for the incoming line, one for the outgoing line. So twisted pair, the reason why it's twisted is, why it's not parallel, why it's twisted is, since bits are transferred in electromagnetic waves, you can see, so this is kind of protection. When it's twisted, there's kind of protection where there's no much of interference or noise, all right, or crosstalks. When it's parallel, there's much of, it's highly prone to attacks, or highly prone to interference. So that's the reason it's twisted. So it's a twisted pair technology, all right. So the electromagnetic waves cannot be interfered. Okay, so that's the reason. For protection reason, it's twisted. All right, this we will see. And there are two categories: unshielded twisted pair and shielded twisted pair. All right, we'll be seeing about this much more detail. And the second one that we will be seeing here is about the coaxial cable. So I have mentioned this coaxial cable everywhere in the last topic. So this coaxial cable, how the technology works and all. So there are actually two copper conductors, but you cannot see two copper conductors. They are concentric. So two copper conductors, but it is also not parallel. So they are concentric, which means that when you see, you can see just one point, not two conductors. All right. And we would see the types also. To just mention the types, they are baseband coaxial cable and broadband coaxial cables. So we'll be seeing about this types also. All right. So having said this, we will move on to the next one, which is a fiber cable. So fiber cable is otherwise called as fiber optics. Okay, so here the transmission is not electromagnetic waves, rather it's light. All right, so the cable is made of glass. It's quite expensive. You can imagine the glass, the cable, the glass cable should be very, very thin, like equal to the thickness of our hair. Imagine you have to use glass material to make a very thin one. So the production cost is very, very high, so it's quite expensive. So mostly it's you these kind of cables are mostly used for undersea, like, or under ocean. So somehow ISPs should have a connectivity. So undersea or under oceans, they would opt to go for fiber cables. All right, it has fast, tremendous data transmission rates. So transmission rates are very, very high, very, very high. All right, since it's expensive, they are not using it locally. Twisted pair and coaxial cables are enough locally, so they didn't go for it. So then talking, these are the three things that we are going to talk under guided media. So when it comes to unguided media, as I've said, it's first one is radio. So when it comes to unguided, okay, the first one is radio. And the second one is satellite. So we'll be seeing about this also, a quick one. So you have two kinds here. So it's one is called as geostationary satellite. One more is called as LEO, and the LEO expansion is low Earth orbit. Low Earth orbit satellite. Okay, we'll see the differences now. So with this introduction, we are moving on to the PPT. The PPT is already there in your drive. So I'll just quickly get on to that. So I'm right now displaying the PPT. I'll just wait for a few seconds for everyone to see this so that I can connect my mouse by that. All right. So getting on to the physical media. So we just saw the introduction about what we are going to see in today's class. All right. This is all right. So when it comes to transmission, all right. So from source to destination, what is traveled is a bit is traveled, okay, through the series of transmitter and receiver pairs. So when I talk about the bit is normally like sent by in the form of electromagnetic waves or optical pulses. All right. So when a data needs to be sent from a source to destination, it usually travels in the form of a bit. All right. So when I say a bit, it's usually denoting an electromagnetic wave or an optical pulse. Electromagnetic wave in the case of twisted pair or a coaxial cable. Optical pulses in the case of fiber optics. All right, across the physical medium. So when it comes to sending from a source to destination, it is not always one single physical medium. For example, in between there could be any number of switches and routers from in between the source and the destination, any number of switches and routers. So the physical medium can take many shapes. For example, from the host to the edge router, it could be twisted pair or a coaxial cable. From the router to another different router, it could be an optic cable. From there, it could be uh, it could be radio waves through a baseband transformer, and from there it could be to again. So it in between the physical medium takes many shapes. It's not a single physical medium that connects between a source and the destination. So the examples of physical media include twisted pair, coaxial cable, fiber optic cable, radio, spectrum, and satellite channel. All right, these are the things. So as I said, these falls under two categories, guided and unguided. So whichever are wired falls under guided, whichever are in the air falls under unguided media. So let's now I'm showing you the twisted pair cable now. As you can see in the picture, can you see they are color coded and they're all twisted. Probably you have seen these kind of cables. This is one of the transmission media or physical media in the computer networks. So twisted pair consists of two insulated copper wires. Can you see two insulated copper wires here? Each 1 millimeter thick. Okay. And they are arranged in a regular spiral pattern. So each pair is used for a single communication link, one for the incoming and one for the outgoing signal. Okay, the commonly used, there are two categories actually, unshielded twisted pair and shielded twisted pair, but the commonly used one is unshielded twisted pair. Okay, the data range, data rates for this one falls between 10 Mbps to 10 Gbps. So you can look at this picture to just have a idea on how a twisted pair looks. Okay, moving on to the next slide. The data rates that can be achieved depends on the thickness and also the distance between the transmitter and receiver. Please underline these two. The thickness of it, normally it would be in 1 mm thickness, but it need not be that. As technologies are getting upgraded on a daily basis, it need not be the same thing. So it depends on the thickness and the distance between the transmitter and receivers. The data rates are calculated for twisted pair. Okay, as I said, the reason for twisting is to just avoid interferences, electromagnetic interferences happening, or any noise coming into it, or any crosstalks happening. All right, I would not say that this is going to you know the rule out this interferences, noise and crosstalks 100%, but to a certain extent, because of this twisting, it can be avoided. All right, applications of where these twisted pairs are used: they are used in telephone lines, they are used in DSL lines, and they are used in local area networks too. Okay, the types, as I mentioned, they are unshielded and shielded twisted pair. Just in the making, they make a difference. Okay, I've moved on to the next slide. Here you can see the categories of twisted pair cables. You need not by heart the data rates of this. This is just for your knowledge. There are 7 categories. Category 1 cable, 2, 3, 4, 5 and 6 and 7. Okay, out of this you can now just see 1 to 6 is unshielded twisted pair, and 7 is only shielded twisted pair. So now you can come to know which is commonly used. It's unshielded twisted pair. Okay, so you need not buy hard where it's used, where all these categories and all is used. This is just for your knowledge. The slide is totally for your knowledge. That's it. All right. Fine. This is all about twisted pair copper wire. This is one medium that we have seen so far. Moving on to the next communication link medium, which is coaxial cable. So why this name here is, so what do you mean by co? For example, coordinator or coordinates. All right, co means working together. Axial, if you get the noun of it, or I don't know what to call. So it is axis, right? So it's just the center point where two copper conductors are going to work on. So it's going to work all together. So that's the name behind this, coaxial. This is the axis where the two can you see the inner conducting core here? You can actually see one, but there are two copper conductors there. They are concentric rather than parallel. Like twisted pair, you cannot see two wires, you can see only one here, but they do the job of both incoming and outgoing, wherein there are two copper conductors inside. All right, so usually the data rates are 100 Mbps per channel. These are commonly used nowadays. Probably in your home also you can see this coaxial cable for your internet connection. All right, look at this picture. There is an inner conducting core. There's an insulator. All these outer covers are just to avoid the electromagnetic interference and other noises coming in, just the protection given here. All right, so this is how a coaxial cable looks like. Moving on to the next slide, coaxial cable on a general basis, it comes in two varieties: baseband coaxial cable and broadband coaxial cable. The difference is only in the thickness of the cable. Okay, you can see baseband coaxial cable, it's 50 ohm cable. It's about a centimeter thick, lightweight and easy to bend, wherein broadband coaxial cable is 75 ohm cable, which is quite thicker than the baseband, quite heavier, and it's not flexible to bend and all. It's quite stiffer also. All right. So they can be used wherever they are needed actually. So these are two categories in a general perspective. But I'm moving on to the next slide. When it comes to the categories, there are other ways of representing coaxial cables. So this is as per the radio government. They in network terminology they called as RG ratings. So RG rating 59, RG 58 and RG11 are three categories of coaxial cables. Okay, so 59 has impedance of 75 watts and they are used in cable TV. So what is impedance? The effective resistance of an electric circuit. So you should have studied this in electricals, I believe. The resistance of an electric circuit. So when it comes to 58 category cable, it has an impedance of 50 watts and used in thin Ethernet. When it comes to RG11 cable, it has an impedance of 50 watt and used in thick Ethernet. So where are these applied, these coaxial cables? In analog telephone networks, okay, in digital telephone networks too, in cable TV networks, in traditional Ethernet LANs, and in metropolitan area networks. These are where generally coaxial cables are used. Having talked about the RG government ratings for coaxial cables, I think we are done with coaxial cable explanation. So we are moving on to fiber optic cable, the last one in guided media. Can you look at this picture? Look at this picture. The transparent ones are made out of glass. Okay, they are shielded in plastic, but they are made out of glass. So here there's no electromagnetic waves. The bits are not transferred in electromagnetic waves. Rather, they are transmitted in the form of light. So you can imagine light travels faster. So the data transmission rates are also unimaginable. They are very, very higher. All right. Look at these thin glass wires. You have to make these wires out of glass. All right. It would be in our hair strand thickness. So for this reason, it's quite expensive. You have to make this glass in a very thin way. So it's very, very expensive. All right. So I have given one more picture here. Just this picture is just to um, for you to understand the light doesn't travel in a straight line. You know, it just hits the walls of the glass and just travels like this. It doesn't, it doesn't just go in a straight line like this. So I just wanted to show you in a form of a picture. So I just took it from the internet. So it just goes hit all the walls and goes in this way. All right. So coming into this theory part, it's thin, flexible medium that conducts pulses of light. So with each pulse of light representing a bit, wherein in the other two, each bit represents in the form of electromagnetic wave. So it's a single optical fiber. The data rates are tremendous. It can be up to tens or even hundreds of gigabytes per second. I'm talking about per second. All right. So it's immune to electromagnetic interference. Mostly it's used for overseas link, as I mentioned. It's expensive. Okay, the OC standard link, or OC is optical carrier standard link, speeds range from 51.8 Mbps to 39.8 Gbps. It's the average. It can just go on. So the standards used today include optical carrier 1, 3, 12, 24, 48, 96, 192 and 768. So these depends on what cables we use. The data transmission rates also differ. Okay, so this is up. This is regarding the fiber optic cable. Okay, moving on to wireless. So the first one we are going to see, I've moved on to the next slide. The first one that we are going to see here is about the radio channel. So here the signal is carried in an electromagnetic spectrum. Can you see here? There are many transformers wherein like you can within the spectrum the radio waves are transmitted. There's no physical wire here, so everything is in the atmosphere. The signals are broadcasted and half duplex. What do you mean by half duplex is it cannot send and receive data at the same time. Only one can happen at a time. Simultaneously both can't happen. Okay. So the propagation environment effects are reflection. Reflection in the sense sometimes signals may get reflected back to its origin rather than being carried away uh, due to imperfections in the cable. So these could be the effects of an wireless transmission. Reflection, so obstruction by objects. For example, if you travel via a thick forest, you would not get the signal properly because there are many trees which objects the signals. All right, this is also possible here. This is one of the propagation, effect in a radio thing. While when you're traveling and you're listening to radio, and if you might hear some disturbances. They could be due to obstruction by the objects also, or even you are out of the range also, you would get some disturbances in a radio channel. All right, so interference is nothing but combination of two or more electromagnetic waves to form a resultant wave that is not clear, or it could be even cancelled. So that's what interference is. So it's basically a noise. All right, these are some propagation effects on a wireless medium. So they are classified into three groups: short distance, local areas, wide area. Short distance is within 1 or 2 meters. Local areas tends to few hundred meters. Wide area tens of kilometers. So I've mentioned the average data rates also. So if it's a short one, it's up to 45 Mbps. If it's a wireless LAN, it's up to 100 Mbps. If it's a 4G or 5G, it's approximate to whatever standards 4G or 5G follows. So these are the points that you need to note about the terrestrial radio channel. Moving on to the last one, satellite radio channel. So satellite links two or more more earth-based microwave transmitters or receivers known as ground stations. So by now I need not explain all these things, but just a quick, you would know how a satellite transmission happens. So basically there are two types of satellite: geostationary satellites and LEO satellites. LEO satellites are nothing but low Earth orbiting satellites. As the name suggests, geostationary satellites permanently remain above the same spot on the Earth. They would be just there. They would not move. So the stationary presence is achieved by placing the satellite in the orbit at 36,000 kilometers above the Earth's surface. So since the distance is much, there would be a signal propagation delay also, which is on an average is 280 milliseconds. Not much, but just 280 milliseconds. Because the distance between the satellite and the receiver or a transmitter would be, it's too much. It's 36,000 kilometers. Okay, so that's the reason there would be a propagation delay. We'll understand what are propagation delays and all. Just understand there would be a delay because of the distance. Then comes LEO satellites, low Earth orbit satellites. So as the name says, they are placed much closer to the Earth and do not remain permanently above one spot on the Earth like a geostationary satellite. They rotate around the Earth just like how the moon does, and they may communicate with each other as well as with the ground stations also. Imagine they can communicate with the other satellites on that orbit, and they can communicate with the ground stations too. And it's being said that these LEO satellites would be used for our near future internet supply. Don't know when, but it's just being said. That's it. To have a continuous coverage on an area, many satellites needs to be placed, and it's quite expensive for this. So in near future, they are planning of this. All right. So this is about all the physical media. So hope you're clear about this. So I'm just going back to what all we have seen so far. A quick gist. I'm right now displaying a slide. Wait, I'll just wait for a few seconds for everyone to see this. So what all we have seen right now in our courses 1.1, 1.2 and 1.3 in the unit 1. So we have third hour class, which I will be starting with 1.4, which is network core. And the first topic I would be dealing is packet switching. So here is where your core concept starts. Okay, so far what all we saw is just what is required for a network, to build a network, or for availing an internet access, or what all components are in between, all those things. But now what we are going to see in the third class starts with the core concepts. So first we will start with packet switching. Okay, move on to circuit switching, the difference between them, and we will move on to network structure. All right, so we'll stop the class now. Thank you.